In this lesson, we are going to continue our discussion on the angle addition postulate in angle bisectors. But there are some times when I can tell you things about angles without actually saying something about the angles. Sometimes you can know what the angles add up to be, what the whole piece is, without me actually saying. And those are when we have different combinations of rays and angles. So the first one, and if you need to pause this at any time, if you're taking notes along with me, then you can just pause it until you're caught up. But complementary angles shouldn't be a new word. They are two angles that add together to be 90 degrees. Now, they can be adjacent or they cannot be adjacent. Remember that to be adjacent means side by side. So this is an example of what they look like if they are adjacent. This is what they look like if they are not adjacent. All they have to do, all it takes to be complementary is to add to 90 degrees. Now, supplementary angles are angles that add to 180 degrees. Again, same as complementary angles, they don't have to be adjacent. So you can have these right here, they are adjacent and supplementary, and these are supplementary but not adjacent. So they can add to 180 degrees and not be adjacent. So that's the only requirement, is that the angles add to 180 degrees. Then we have opposite rays, and I have several examples here. Opposite rays are rays that share a common vertex, but they extend in opposite directions. Now, I want to show you the difference is these angles right here, or these rays right here, they share a common vertex, but AB and AC both go the same direction. AB starts here at A, goes towards B, and continues going forever. And then AC starts here at A and goes towards C and keeps going forever. So those share a common vertex, but they go in the same direction. These share a common vertex, these at B, these share a common vertex, B to A and ray BC, but they just go in different directions. They don't go in opposite directions. They don't go in the same direction. They just go in different directions and they form an angle. So what I mean by opposite rays and that they go in opposite directions would be this picture right here. BA goes in this direction, it stops, it has an end point at B and extends infinitely in the direction of A, and then BC starts at B and goes infinitely in the direction of C. Notice that those opposite rays also help form this straight angle that we talked about yesterday or the other day. Okay, then we have a linear pair. Linear pair and vertical angles, which we're going to talk about next. Those are two extremely important words. You're going to need to know those, and you're going to need to know them all year long. So make sure that you understand them, you know what they look like, and you recognize them, because a lot of times I'm going to say, what do you know? They equal 180. Why do you know that? Because they're a linear pair. What do you know? They're equal to each other. Why do you know it? Vertical angles. So you need to know those words and these definitions. So a linear pair are adjacent angles, which means they have to touch, they have to be side by side, and they are supplementary. Remember, to be supplementary, all you had to do was add to 180, but to be a linear pair, you have to be both supplementary and adjacent. So linear pairs will always look something like this. Notice that their non-shared side forms opposite rays, okay? And they are always going to, they're supplementary, which means they are going to always add up to be 180 degrees. Okay, notice these two angles here. So we have this angle here and we have this angle here. They are going to add up to 180 degrees. Now, don't be confused, okay? If you have a line, and I'm talking about segments, and it happens to have a segment bisector or a line that bisects it through the midpoint, this is very different. If I say segment AB, that's segment AB and BC. Those are segments. Segments never add up to 180 degrees. Where this one might say A, B, C here, it's going to say angle ABC and angle CBD are a linear pair. So it has to say angles. Angles are linear pairs, but segments are never a linear pair. So don't get confused by that. It's a common mistake. Okay, and then lastly we have vertical angles. Vertical angles are opposite angles. We said adjacent is side by side like your shoulder partner, and opposite is the person who's across from you. So they are opposite angles, and they're formed by opposite rays. Okay, now let's see what their relationship is. So if this angle is 50, these two angles right here form this linear pair. So that means their total is 180, which means this angle is 130. Then we have the same thing that happens this way. This is also a linear pair, and that means this angle is also 130 degrees. And then we have this last linear pair. We've got several linear pairs here. If that's 130 degrees and this is a linear pair, then this is 50 degrees. So here's what I want you to see. The vertical angles are the angles that are formed by the opposite rays, and they are opposite angles. So these angle pairs, that angle pair, they are both 50, and they are equal to each other or congruent. And then we have this 130 degree angle and this 130 degree angle. They are opposite each other, and they are vertical, and so that means they are congruent to each other. So the important thing about vertical angles is that they are congruent to each other. Now, just a side note, just to give you an example, they're formed by opposite rays. And so you need to recognize that, like, so these are opposite rays, but this would not be an opposite ray, okay? So these, if I drew that straight, it doesn't look very straight, but pretend it is. So these are not vertical angles. These are not vertical angles because while they are opposite of each other, they are not congruent because they are not formed by that X that is formed by those opposite rays. Let's look at some sometimes, always, nevers with these. So linear pairs are supplementary. So we know what a linear pair is. A linear pair always looks like this. And by definition, linear pairs are supplementary. I didn't ask about being adjacent, but a linear pair is supplementary, so that is always true. A linear pair will always add up to 180 degrees. Remember that angles are portions of circles, and so that linear pair is half of a circle. That's why it's 180 degrees. Supplementary angles are adjacent. So remember, adjacent means side by side. Supplementary means they add to 180 degrees, but remember, to be supplementary, all they had to do was add to 180 degrees. Whether they were side by side did not matter. So yes, they can be adjacent, but they don't have to be, right? That's what we drew up here. These were adjacent and these were not, but they were both supplementary angles. Okay, linear pairs are adjacent. That is always. They have to be touching each other here to form that straight angle together. So they are both adjacent and supplementary. Remember that we talked, that's the definition, adjacent angles that are supplementary. Vertical angles are adjacent. Well, adjacent means side by side. Vertical angles are opposite, right? Vertical angles are opposite. They are these pieces. They kind of form those back-to-back V's. See, we've got these V's here. So those are vertical. These two are vertical. And so vertical angles are not adjacent. They're never adjacent. They are always opposite of each other. Supplementary angles are linear pairs, this last one. So supplementary angles mean that they add up to 180 degrees. Linear pair means they add up to 180 degrees and they are adjacent. But remember that you can be a supplementary angle without being a linear pair. So sometimes they are linear pairs, but sometimes they are not. So here is an example of when they are not. Maybe this is 110 and this is 70. Those are supplementary, but they are not a linear pair. So they can be, but they don't have to be. Okay, that's how your sometimes, always, and never work. So if I want to use the diagram at the right to name a pair of each of the following, you have multiple answers. So adjacent simply means that they are side by side. So I could say that angle 1 and angle 2 are side by side. They share side XC. And they don't overlap. They have a vertex at X. I could say angle 2 and angle CXE or angle 5. Remember that you can name them by their angles by their full name, or you can name them by their nickname. Angle 1, angle 2, angle 5, angle 6, angle 3. Those are some examples of adjacent angles. Here is, we'll color them in. Those two are adjacent. Vertical angles, you have to be careful here. Make sure you are dealing with your opposite rays. And so we've got one set here, right? We've got our opposite rays where we can form our X. So angle 3 and angle 5 are vertical angles. That is one example. I could also say angle 6, but be careful, it's not angle 6 and angle 1 or angle 6 and angle 2. It would have to be the entire angle. So I would name that AXC. So I could say angle 6 and angle AXC. That's the only way to name that whole big angle. And then a linear pair, what we're looking for is angles that form that straight line. So if they're going to form this straight line, they're right here, right? And there are lots, right? We have this straight line, those form a linear pair, those form a linear pair, those form a linear pair, these form a linear pair. We have lots of options. So angle 3 and angle 6. You've got angle 6 and angle 5. You've got angle 3 and angle AXC, that red angle right here, angle 3 and angle AXC, they form a linear pair. You're just looking for them to be adjacent and have that opposite ray on their non-shared side.
Okay, now that we know how to recognize the angles, let's look at the math that goes with them. This first question, this first problem that has numbers with it, number 3, you have to decide what kind of angles, what's the relationship? Well, they're adjacent because we have two angles that are side by side. And then what we notice is that these form a straight angle. And when they form a straight angle, these become a linear pair. That means that these added together is 180. This is that part plus part equals whole where I don't explicitly tell you how much the whole thing is, but we know that this entire angle is 180 degrees because these two form a linear pair. So we know that this angle, UOW, plus this WOV, 34 degrees, has to equal 180 degrees. So we take 180 degrees and we subtract 34 degrees, and we find out then that UOW, this obtuse angle right here, is 148 degrees. Okay? Then we've got, so that's linear pairs. Look at number 4. In number 4, we actually have linear pairs and vertical angles. The vertical angles, angle 1 and angle 3. So we know that angle 1 is congruent to angle 3. We know that angle 2 is congruent to angle 4 because they're vertical angles. But then what we also know is that angle 1 and angle 4, angle 4 and angle 3, angle 3 and angle 2, and angle 2 and angle 1, each of those pairs is a linear pair, and they add up to 180. Now, where you start this problem, that's up to you. You can start with the vertical angles if that's easier for you, or you can start with the linear pairs if that's easier for you. I always recommend you label your pieces. Angle 1 is 32, so we're going to put that 32 right here, and then we're going to figure out the rest of it. Now for me, I usually would notice vertical angles first. So if this is 32 degrees, I know that this is 32 degrees. And then from there, look here, see that linear pair? We also have that linear pair or that linear pair. That's what I was talking about earlier. So you just pick whichever linear pair you want to use, but 180 minus 32, if you take 180 and subtract 32, you would find out that angle 4 is 148. Now, Angle 1 and angle 2 are a linear pair, so you can do 180 minus 32 and get 148. Or you can recognize that 4 and 2 are equal to each other, and so that means that angle 2 is also 148. So there are multiple reasons for angle 2 to be 148. So now we can go in. Angle 2 was 148 degrees. Angle 3 was 32 degrees because it was vertical. And angle 4 was 148 degrees because those formed a linear pair. Okay, so sometimes you just have to decide, and sometimes you can use both. It doesn't matter which one you use. So let's look at number 5, angle PSQ. So here is PSQ and QSR. The angle names are important because there are actually these two individual angles and then this one big whole angle. They are complementary angles. So maybe we don't remember what complementary means or that that's important. So let's keep going and let's label what we know. What is the measure of each angle if QSR is 7x minus 26 and PSQ is 3x plus 6? So we're looking at this problem, and we know that they're not equal to each other. There is nothing that says that those are equal to each other. There's no bisector. There's no congruent segments or congruent angles that are marked. There's no congruency statement. So it's not part plus part equals whole yet, except it's not part equals part. So is it part plus part equals whole? Well, do we know how big the whole big PSR is? Well, notice I said complementary angles. Remember, complementary angles by definition are angles that add to 90 degrees. So that means that these two angles added together is 90 degrees. That's our whole measurement. So now we know our whole. I know it without explicitly telling you. Those are the things that you have to watch for. They equal 90 degrees. So now we've done our setup. Now let's do our algebra, combine our like terms. 3x and 7x is 10x. 6 and minus 26 is minus 20 equals 90. Add 20 to both sides to isolate your variable. 10x is equal to 110, which means that x is 11. Now be careful on a test or a quiz. I didn't ask you for x. Look at what I did ask for. I asked for the measures of each of the angles. So make sure on a test that you don't go putting 11 in the blank just because that's the answer that you got. So PSQ, remember that PSQ is 3 times x plus 6, or 3 times 11 plus 6, 33, plus 6 is 39 degrees. And then QSR, two ways to find QSR. You can substitute the 11 in, or you can subtract the 39 from 90, because we know that those two angles together have to add up. I did 90 minus 39, but let's do a quick double check. 7 times 11 minus 26 is indeed 51 degrees, so we know we did it right. Number 6, again, we've got this cross where we have vertical angles and linear pairs. And so look at what you want to use. Notice these two angles are a linear pair, but if you use these two angles, notice that you have two variables. So we don't want to use this linear pair right here. We could use this linear pair, and that would give, you have one variable and you have this, and you know that these two together are going to add up to 180 degrees. We also know these two angles, the 63 degrees and this y plus 23, that those are vertical angles. So those are equal to each other. So we know two things. We know these two angles are equal to each other, and we know that these two angles add up to 180 degrees. So you can pick which variable you answer first. I'm going to start with x, alphabetical. So we have 2x minus 17 plus 63 is equal to 180 degrees. Those form a linear pair. Combine your like terms. 63 minus 17 is 46. So 2x plus 46 is equal to 180. Subtract 46 from 180 to isolate your 2x. That's 134. Divide both sides by 2, and you get that x is equal to 67. So x is equal to 67. There's another way you could have done that. If you know that these two add up to 180, I've already used up 63 degrees of it. So I could take 180 and subtract 63 and get 117. So what I know is that this angle right here is 117. So my question is, what does x have to be so that that angle can be 117? So you can do it this way, or you could say 2x minus 17 equals 117. So you could do the same thing, okay? You'll get the same answer either way. And then we know that these two are equal to each other. That means this angle is 63. So what does y have to be so that the angle can equal 63? Well, 63 minus 23 is 40. So y is 40. And actually, sorry, x is 67, not 67 degrees. The angle is 67 in degrees, 117 degrees. Okay, so get really good with linear pairs and vertical angles. We're going to be using them all year long. So this one's just a little puzzle. You can put it on pause and try it. But let's mark everything we know, and then let's see, using linear pairs and vertical angles, if we can fill in the rest of the gaps. You're given that 4 is congruent to 5. So I'm going to mark that 4 is congruent to 5. Anytime I know that angles are congruent, I want to mark them so that I can keep it straight. And then COE is 160 degrees. COE, remember, trace the angles if you're having trouble seeing it. COE is 160 degrees. Now, there are many ways that you can start this problem. You do not have to start with angle 1. You can start anywhere on here. I recommend that you start with the picture and then you work from the picture. Now, the first thing that I see is I know that if these two angles together are 160 and each of these angles is equal to each other, that means I can divide 160 by 2, and each of those is 80. Now, from there, you've got angles whose sum is 180 because these angles together form a straight angle. So all of those angles are going to add up to 180 degrees. You also have vertical angles. Notice that angle 4 and angle 2 are vertical. I tend to go to vertical angles first just because it helps me to wipe out a lot of information all at once. I know that 5 and 1 are vertical angles, and so angle 1 is also 80 degrees. Also notice COE and BOF are vertical angles, so the whole thing would be 160. That leaves us with 3 and 6. So we've kind of come to the end of our rope with vertical angles, although we know 3 and 6 are vertical. So then we're going to have to go to something else. Well, again, I notice that this is a straight angle, right? These are opposite angles. It's a straight angle, or excuse me, opposite rays. So it forms that straight angle. That straight angle means it's 180 degrees. I've used up 160 of it. That means I have 20 degrees left. 20 degrees left here gives me also 20 degrees for angle 6 because they're vertical angles, or we also have that straight angle over there. Okay, so now we know that angle 1 is 80 degrees, angle 2 is 80 degrees, angle 3 is 20 degrees, 4 is 80, 5 is 80 degrees, and 6 was 20 degrees. Okay, now AOC. AOC is that angle right there. It's 80 plus 20. So that's 100 degrees. EOC is the same as COE, so that's 160 degrees. And AOD, A to O to D, that's a straight angle, so that is 180 degrees. Okay, there are a lot of different ways you can process that problem. I went with a particular direction. You might have done it differently, and that's totally okay. Notice that I did everything on the picture, and then I came over here and filled in the blanks. It kept me from getting stuck, and I could process it the way that my brain worked. Okay, so linear pairs are adjacent angles that form a straight angle, and they have a sum of 180 degrees. Vertical angles are angles formed by opposite rays, and they are congruent to each other. Those are two very, very important things that you need to remember.